Okay, let's finish up 8.1b here in the second part of the lesson. So we finished talking about this equation here in blue. Our parent crosses at 0, 1 and grows exponentially. And then we sketched in green what it would look like. So let's pause a minute and let's do a table to see, okay, how in the world do we know to sketch that? And I'll show you kind of the idea, and I think that most of us could be able to sketch them. But again, with all of these, if you can't sketch, then just make a table. Tricky thing about making a table is you got to make sure you're picking points that are applicable to the specific graph that you're looking at. So for instance, this one I know shifts right 2. So I probably want to test 2. That's almost kind of my main point, right? That's essentially 0, 1 is what that's going to be. Now, why was it not 2? We said it flipped, but why was it not 2, negative 1 if it flipped? Well, because it's compressed. So let's look here. Plug in a 2. 2 minus 2 is 0. 5 to the 0 is 1. So here it's just a negative 1/2 times 1. Or in other words, a negative 0.5 or a negative 1/2. So sure enough, when we graphed it, look what happened. We went right to 0.5 right there. Essentially, remember what I said before, is that it compresses it. Because of the fraction, it squashes it down a little bit, compresses it. It's half of what it would have been. Okay, let's try 2 more points. Let's try negative 1, and then let's try 3. And see if we're close to what I sketched there. So a negative 1 would be a negative 3. Notice this here, right? Why did I do negative 1? Sorry, that's not the right point. I want a positive 2. Essentially, whatever my main point was, in this case 2, I want to go around that, right? So it would be a positive 1. It would be the one right behind that. Okay? So a positive 1 gives me a negative 1. So look here, I would get a negative 1/2 times 5 to the negative 1, because I plug in the x. 1 minus 2 is a negative 1. 5 to the negative 1 is a 1/5. Okay? Multiply those together and you get a negative 1/10. Or negative 0.1. Negative 1/10. So look here, positive 1, 1/10. That's probably a little bit high, but it was somewhere right in there. All right, and the last one, 3. 3 minus 2 is 1, 5 to the first. So it's a negative 1/2 times 5 to the first. Or in other words, 5 over 2, or 2.5. So a negative 2.5. So here I go to 3, and I go a negative 2.5. Look at that, not bad. So there's my graph of this exponential growth function, but it's just flipped because of this negative sign. Okay? Let's try at least one more, maybe 2. All right? Here we go in the notes. Y equals 0.1 times 6 to the x power minus 3. Okay? If you're feeling confident, like you think you could sketch that, or at least make a table, go ahead and pause the video and see if you can graph it and see if it's going to look something close to mine. All right, if you did it, if not, I know who you are. No, hopefully you gave it a try. But essentially, all right, let's say that we wanted to sketch this, and then let's test our table and see how accurate we are. Can you see how close we are? So the sketch tells me it goes down 3. Now, the whole thing, including asymptotes, goes down 3. Okay, that sometimes is tricky. It does not go left to right at all. Okay, and the 0.1 is kind of like a fraction. Okay, it's going to compress it. Notice it's not negative, so it doesn't flip at all. Okay, so if I was going to sketch this, I would take the whole thing down 3. Now, what does that mean? That means rather than having my x-axis be my asymptote now goes down negative 3. Okay, so a negative 3 right in here. Try to do the straight line feature and it didn't work out too well. All right, so here's my asymptote, down negative 3. Okay, my curve would still then, just like up here it crossed at 1, my curve would still cross up 1, except it's compressed, and it's compressed quite a bit. 0.1, that's like 1/10. So rather than crossing, notice if we were here, let me draw the parent real quick in black. So remember the parent would look something like this. Okay. So, but rather, however, than crossing up 1, it's compressed. It crosses right here at 1/10, 0.1. And then that's it. Doesn't go left or right at all. The 6 just makes it grow a little more rapid. So in other words, it would just be a little bit more like this. Not too worried about that, okay, because it's very slight, unless it's a huge number. And then the down 3, we already did. The whole thing went down 3. Now, the tricky part is lots of students will say, oh, because it goes down 3, my graph has to be at 3, right? My curve has to be at -3, probably because that's a 6. I probably want to make that a little bit sharper here, but it's not a huge deal. Okay, something like that. I don't know why I dotted it. Sorry. Let's try that again. There we go. Okay, should have done that in a different color. Oh well. So essentially, this is my answer right here. Okay, it went down. The whole thing went down 3. It became compressed, and that was it. And that is my normal growth curve. All right, last one. Let's just do this one over here in black, so we're not confused which one's which. Let's just say we had a little bit of a simpler one, 3 times 4 to the x. All right, again, if you want to try it, go ahead. Okay, so the whole thing, oops, can you undo? Does that undo? All right, so the whole thing doesn't move right or left, doesn't move up or down. So it's going to cross at 0, 1, except it's stretched. Guess where it's stretched to? 3. Think about it. If I test a 0 for x, 4 to the 0 is 1. 1 times 3 is 3. The whole thing is just stretched up to 3, rather than being my original 0, 1. Okay, so this equation, 3 to the 4x, is just stretched up 3. Okay, these are tricky, these are weird, these are different. Okay, square root was different to graph last chapter. These are tricky to graph, and I think one of the hardest parts is the asymptote. Okay, so let's review real quick. Remember for this one, the asymptote didn't move because there was no plus k right here. It didn't move at all. Okay, then we went on and we said, all right, now the -3, that is going to shift down 3. Everything moves. This last one, the asymptote didn't move, but the whole graph stretched up to 3. And again, the key, the code, we probably should have wrote down as a definition. If sketching seems sketchy, make a table. Again, tricky to sometimes get the table correct, but the table will give you the right answer if you're not sure how to graph. All right, that is 8.1b graph. If you have any questions, you can put them in the Google Classroom or email me as well. And then we'll continue on here, moving in other sections that are not graphing.